All right, these are 5F notes. We're going to be dividing polynomials and learning synthetic division. All right, so first of all, look on your notes. One thing, you're probably going to need more paper than you have here. So you might want to pause and get a couple sheets of extra paper. All right, when you divide a polynomial f of x by a divisor d of x, so a polynomial by a polynomial, you're going to get a quotient polynomial q of x and a remainder possibly r of x. So these are just polynomials. So we're going to divide f of x by d of x, and we're going to get a quotient plus our remainder over our divisor. All right, the degree of the remainder must be less than the degree of the divisor. We're going to be looking at what we call polynomial long division. So let's think about the process here of division. So if I was going to divide 3 into 7, so 3 into 7 goes 2 times. You multiply 2 times 3 and get 6, and then you subtract, and we have a remainder of 1. So because 3 will not go into 1. So here we write this, it's 2 plus a remainder over 3, but we simplify that and write it as 2 1/3. But what's happening here actually is we're adding. So we're going to do the same process, but now we're going to have variables. We're going to do polynomials. All right, so write down the following problem. F of x equals 3x to the fourth minus 5x to the third plus 4x minus 6, and we're going to divide that by x squared minus 3x plus 5. All right, let's get this thing set up for. Now please write this down. You need to make sure you include all 0 placeholders if needed. So our divisor is going to be x squared minus 3x plus 5, and we're going to divide that into the polynomial 3x to the fourth, and we want this in standard form, minus 5x to the third. There's no x squared term, so I'm going to put a 0 placeholder, plus 4x minus 6. So like I said, please write down the facts that you have include 0 placeholders. All right, we're going to divide this first term into the first term here. So we're asking ourselves, this over to the side, what do you multiply times x squared to get 3x to the fourth? Well, hopefully you said 3x squared. Now what we're going to do with that 3x squared is we're going to distribute it on each of these terms. Okay? So our step number 1 was divide. And then step number 2 is going to be to distribute. Please, what I write down, you write down. Don't just write down the problems. Okay, we're multiplying. So we're going to get 3x to the fourth minus 9x to the third plus 15x squared. All right, now remember we need to subtract. So my step 3 is subtract. So that means I'm going to go through and I'm going to change all of these signs. So minus, plus, minus. All right, now combine like terms. So we're going to get our first term should be 0 each time. We're going to get 4x to the third minus 15x squared. All right, now since I had 3 terms in my divisor, I want to bring down my next term. I'm going to bring down my 4x, just like you did long division back in elementary school. Okay, so now let's do the same thing again. We're going to look at x squared into 4x to the third. So that means I'm going to need 4x, so plus 4x. All right, I'm just going to repeat. So step number 4 is going to repeat until we run out of terms. Repeat as needed. So I'm going to do the exact same thing again, but this time I'm distributing the 4x on each one of these divisor terms. So I'm going to multiply 4x times 4x squared and get 4x to the third. 4x times negative 3x, I get negative 12x squared. And then 4x times 5, I'm going to get 20x. All right, I'm back up to my subtract step. So minus, plus, minus. All right, combine like terms. So I'm going to get negative 3x squared minus 16x. All right, I need to bring down another term. And since this is my last term, bring down the -6, this is the last time I'm going to divide through. But I got to keep dividing until I get this degree smaller than this degree. Okay, so let's do it one more time. Whoops. Get my problem back. There we go. Okay, let's see. All right, so what are you going to multiply x squared by to get -3x squared? All right, so -3. All right, distribute. -3 times -3 times x squared is -3x squared. -3 times -3x is positive 9x. And -3 times 5 is -15. Subtract. So it becomes plus, minus, plus, and then combine like terms. So I get -25x plus 9. That's my remainder. See, the degree here is 1, the degree here is 2, so I can't divide anymore. All right, now we have to write your answer. So your final answer is your quotient, 3x squared plus 4x minus 3, plus our remainder over our divisor. And this is your final answer. Okay? Now, we're going to use long division to find what we call later on Sleighan asymptotes, but when you get to your higher level maths, you're also going to be using long division again. But so right now we're learning the process, and the application will come later. But like I said, steps: divide, distribute, subtract, and repeat until you run out of terms. Okay, let's look at another one. All right, write down this problem. So f of x equals x to the third minus 27. We're going to divide that by x squared plus 3x plus 9. All right, let's get it set up. Divisor. Don't forget about the 0 placeholders. So I've got x to the third plus 0x squared plus 0x minus 27. Don't forget about the 0 placeholders. Okay, divide. What do I multiply x squared by to get x to the third? I need an x. Distribute. X to the third plus 3x squared plus 9x. Subtract. Minus, minus, minus. Combine like terms. So we're going to get -3x squared minus 9x. All right, I need another term. I need 3 and 3, so I've got to bring down the -27. All right, repeat. What do you multiply x squared by to get -3x squared? I need a -3. Distribute. And subtract. So it becomes plus, plus, plus. All right, combine like terms, and notice I'm getting a remainder of 0. So that means that these are factors. Okay, so my answer is x minus 3 with no remainder. It also means that x cubed minus 27 can be factored to x minus 3 times x squared plus 3x plus 9. Okay, which you should already know because that's our a difference of cubes pattern. But it shows, so if there's a 0 remainder, that means that your two quotients are factors of the original polynomial. So you can maybe see some application there. All right, so that's long division. All right, we're going to learn another process now, what we call synthetic division. So we're going to use synthetic division here. All right, so take a moment. We're going to divide f of x by x plus 3, by this linear quotient. Now, you can only use synthetic. Synthetic is kind of a shortcut technique for long division. You could do this with long division, and you get the same answer. But synthetic is usually, it takes the variables out of it. So it's a shortcut process. Now, this has to be a linear term in order to be used synthetic. So if this had been x squared plus 3, I couldn't use synthetic. I would have to use long division. All right, so let's set this up. All right, here again, you still need 0 placeholders. in both of our methods here, so 0 placeholders are needed. All right, what we're going to start off doing, so step number 1 is we're going to write the coefficients only of our polynomial f of x. And these have to be in standard form. All right, so we just kind of do this upside down division to kind of keep my synthetic division contained. All right, so we're going to write down the coefficients. So 2, 1, I don't have an x term, so I put a 0, 5. You got to remember to put that 0. Synthetic won't work if you don't put those 0 placeholders. All right, the number outside. I want the 0. All right, what's going to go out here is the 0. So what's x plus 3 equals 0? That means x is equal to negative 3. So we're putting a negative 3 out there. That's all about the setup now. Now here comes the process. All right, we're going to drop down the 2. So drop down the 2. Then we're going to multiply. We're going to multiply these two together. And then repeat. Okay, so multiply, we get negative 6. Add, we get negative 5. Multiply again, so that process multiply, add, multiply, add. Multiply, we get 15. Add. Multiply again, we get negative 45. And then add, so we get negative 40. This is my remainder. Okay, that last term is going to be my remainder. All right, now we're going to turn this back into a polynomial because our answer is going to look like what we did previously when we did long division. Now, since this was a cubed, my degree here was cubed, and I divided by an x, that means I'm down to an x squared. This is going to be a quadratic. So every time you take out an x, you go down a degree because you're dividing by x. X to the third divided by x is x squared. So when I convert this back to a polynomial, all right, my answer is going to be 2x squared minus 5x plus 15 plus my remainder over my divisor, which was x plus 3. So synthetic, okay, it's a process, a shortcut process. I'm not dealing with, I'm only dealing with the coefficients, and I bring the variables back in at the end. All right, synthetic substitution, we can also use this if I wanted to evaluate f of negative 3. Whatever my remainder is going to be what my answer is. So instead of plugging negative 3 into this original polynomial, I can use synthetic, and so f of negative 3 is going to equal to negative 40. So a point on this polynomial is going to be negative 3, negative 40. So here again, instead of having to cube it, my numbers are staying smaller. So synthetic substitution, like I said, gives you a shortcut method to do two different things: division and then substitution. All right, here's going to be our application of this. All right, so write down the following question. All right, first of all, this theorem, write down this theorem. So factor theorem. A polynomial f of x is a factor of x minus k if and only if f of k is equal to 0. We can use synthetic division to help you factor a polynomial. So here's our polynomial we want to factor. We want to factor the polynomial giving one factor. All right, so now we use this, okay, this is another method. If we can't outright factor this has 4 terms. I can't factor this by, since 4 terms, I would try grouping. It doesn't factor by grouping. But it doesn't mean it doesn't factor. So this is another method, just like we had completed the square and the quadratic formula, another method to help us factor. All right, we're going to start you off first by giving you something. You have to find the other 2. All right, so we're asked to factor this. This is a cubic function, so I know it's going to have 3 factors. So in my final answer, I've got one of them. You're looking for the other 2, is what we're doing. And we're going to do that by using synthetic. Okay, so let's set it up. So I need to write down my coefficients. I don't have any 0 placeholders. So I got 3, negative 4, negative 28, and negative 16. All right, I want the 0 of this. So that means outside here, this is going to be a negative 2. All right, drop down the 3, multiply and add until I run out of terms. So multiply, add, multiply, add, multiply, and add. This is what my theorem is telling me. If I get a remainder of 0, then that means this is a factor of my polynomial. In order to be a factor or a 0, you have to have a remainder of 0. Okay, now this is a quadratic because I had an x to the third and I divided by an x. So that means this is down to a quadratic. And we know how to solve and factor any kind of quadratic. So let's turn that back into a polynomial, to a quadratic polynomial. And we're going to finish our problem because we're looking for 2 more factors. All right, so this becomes 3x squared minus 10x minus 8. And I'm just factoring, so I don't need to set it equal to 0. All right, let's factor this. What multiplies to give me negative 24, but has a difference of negative 10? What, negative 12 and 2? All right, so let's factor this. All right, so we're going to get 3x squared minus 12x plus 2x minus 8. I'm just factoring. 3x, x minus 4, 2, x minus 4. So my factors are 3x plus 2, x minus 4. All right, so my final answer. Don't forget the one you already were given, so make sure you include that in your answer. So your final answer, this is factored out, is 3x plus 2, x minus 4. And if you were to multiply those 3 back together, you should end up with that original polynomial. So here's one application of synthetic division. All right, let's do one more problem. All right, another way of asking the same thing. All right, if given a polynomial f and a 0 of f, find the other zeros. So now we're going to be solving. So write down the following question. F of x equals x to the third minus x squared minus 2x, and we're told that f of 2 is equal to 0. All right, so write that down. So this means that x is equal to 2 is a 0 of my polynomial. They're giving me 1. How many total do I have? Well, look at the degree. The degree is 3, so I need 3. I need to find 2 more zeros. All right, without using the calculator. All right, we're going to use synthetic division for this. Okay, here again I need my 0 placeholders. So 2 is going to go on the outside because that's the 0. I got 1, negative 1, negative 2, and I need that 0 for that constant. All right, I still need that 0 placeholder. It should count, like I said, be in standard form. All right, drop down the 1, multiply, add, multiply, add, and then multiply and add. All right, now we're going to turn this back into a polynomial. All right, what degree is this polynomial here? Well, it's an x. We divided an x into x to the third, so it leaves us x squared. Our goal is to get this thing down to a quadratic every time. Once you get it to a quadratic, you should be able to solve any kind of quadratic. So this is going to be x squared plus x equals 0. Because I would have plus 0. Remember, this is my remainder. And my remainder has to be 0 for this to work. All right, let's factor that. All right, and some people still have trouble with factoring this. This just has a common factor, x. Do not divide by the x, however, because that's going to be one of our solutions. Use your 0 product property and set each factor equal to 0. So I've got x equals 0 and x equals negative 1. So what's my solution set? Now remember, I needed 3 solutions. I've got negative 1, I've got 0, and then I've got my give me 1, 2. So don't forget about the one that was told to you. All right, I believe that's the last one. Oh, got this problem. All right, let's go back. This is on the back of your notes. This is an SOL-like problem. So let's look at this one. Find an expression for the missing dimension. So I'm looking for this missing dimension on this box. They're telling me 2 dimensions, so they're telling me x minus 1 and x plus 6. So I'm looking for that third one. As long as you have zeros, you can do synthetic division. So here, what are my zeros? Well, if a factor is x minus 1, then x equals 1 is a factor, or 0. And my other factor is x plus 6 equals 0, so x equals negative 6 is a factor. Alright, so let's do synthetic. Doesn't matter which one I start with. Pick one to start with. I want to pick the 1. Alright, doing 0 placeholders? No. Write down your coefficients. Do synthetic. So drop the 1, multiply, add, multiply, add, multiply. Alright, I'm happy that I got a remainder of 0. Alright, now, since I have another 0, I can do synthetic again. So I'm going to put negative 6 out here this time. So that's 1, multiply, add, multiply. I get 0. I'm happy I have a remainder of 0. Alright, now we got to turn this back into a factor. Alright, think about what we've got here. This was a 3rd degree. We took an x out, so this one was a 2nd degree. We took an x out again, so that makes this one a 1st degree. So my factor is going to be x plus 8. Okay? Now, like I said, the whole point of this is, like I said, we're building on this. We're going to be solving and factoring polynomials in the future, so that's why I wanted you to see that you could do this. You may have been able to look at it and figure out the answer, but the whole idea of this was the process. Okay, if you have any questions, please make notes here so you remember to ask them in class.